Hi, in this video I'm going to try to explain my answers to the Chapter 7 review questions. Number 1, what is the domain of x minus 5 over 2x plus 18? Remember what domain means? The domain of an expression is everything we are allowed to plug in place of x. So for a rational expression like this, to figure out the domain, we take the denominator, set it equal to 0, and solve for x. When I do that here, I get x equals -9. So that is what would make the denominator 0, and that's what we don't want to happen. If the denominator is 0, the expression is undefined, so the domain is everything else, all real numbers except -9. Here we have some expressions to simplify. And the way we'll do that is by factoring anything we can in the numerator and in the denominator, and then seeing if there are any common factors we can cancel out. With 3x plus 12 over x squared plus 4x, I can factor out a 3 on top, so that it's 3 times x plus 4. I can factor the common factor of x on the bottom, so that it's x times x plus 4. And then that common factor of x plus 4 divides out, leaving me with 3 over x. For the next one, 4x minus 28 over x squared minus 5x minus 14, on top, I factor out a 4, so that it's 4 times x minus 7. The denominator can be factored into x minus 7 times x plus 2, and then when I cancel that common factor of x minus 7, I have 4 over x plus 2. C is y minus 38 over 38 minus y. If the numerator and denominator were exactly the same, that would reduce to just 1. They're not exactly the same because the subtraction is in the opposite order, but y minus 38 would be the negative of 38 minus y. It would be equal to -1 times 38 minus y. So there, when we cancel, we are left with -1. For the next few problems, the directions say perform the indicated operations. So we're going to look at what we're going to have to do. Do we have to multiply, divide, add, subtract? And we're going to do that, and we're going to make sure our answers are in lowest terms. Here we are multiplying. We're taking these two rational expressions and multiplying them together. And the way to do that is look at the numerators and denominators and factor them if possible. Here, the x minus 3 doesn't factor, but the x squared plus 3x plus 2 can be factored into x plus 1 times x plus 2. The x squared minus 4 is a difference of two squares. It's one perfect square minus another. So it factors into x minus 2 times x plus 2. And the 3x minus 9 has a common factor of 3 that we can pull out so that it's 3 times x minus 3. Now that everything has been factored, look at all the factors we have in the numerator of the whole thing and all the factors in the denominator, and we have a common factor of x plus 2 that we can cancel out, and we can also cancel out the common factor of x minus 3 on top and on the bottom. So what's left on top is x minus 2 over 3 times x plus 1 on the bottom. In number 6, we are dividing. W minus 4 over 3w divided by 2w minus 8 over 9w. The first thing we do with a division problem like this is turn it into a multiplication problem where the first fraction stays the same, but the second fraction gets flipped over. So we're taking w minus 4 over 3w times 9w over 2w minus 8. Now that 2w minus 8 can be factored because we can pull out the common factor of 2 and write it as 2 times w minus 4. The only other thing we can really factor is the 9w. 9 would be 3 times 3. So one of those 3's can cancel with the 3 on the bottom. The w on top can cancel with the w on the bottom. And the w minus 4 on top can cancel with the factor of w minus 4 on the bottom. So after all of those cancel, what's left is a 3 on top. Remember, 9 was 3 times 3, and we canceled one of those 3's, so there's still one left on top, over 2 on the bottom. So 3 over 2. Number 7, here we are adding. And these do not have the same denominator as each other. So before we can add them together, we need to get them so that they have the same denominator. The first one is made up of 6ab. That's like a 2 times a 3 times an a times a b. And the second denominator is 4a squared c. So that's like a 2 times a 2 times an a times an a times a c. So they both already have a factor of 2 and a, but the second one has another 2 and another a and a c that are missing from the first denominator. And the first denominator has a factor of 3 and b that are missing from the second denominator. So if I want them to match, I can multiply the first denominator by 2ac, which will turn that into 12a squared bc. And I can multiply the second denominator by 3b, which will turn that second denominator into 12a squared bc. Now that both denominators are the same, and when I multiplied the denominators, I had to multiply the numerators by the same thing. So the first numerator, 1, got multiplied by 2ac, so that's 2ac. The second numerator, 3, got multiplied by 3b, so that's 9b. And then I could add, the denominator of the whole thing was just the same denominator that each one individually had, 12a squared bc, and the numerator was made up of this numerator plus this numerator, 2ac plus 9b. Those can't be combined. There's nothing more I can do to simplify this, so that is my final answer. 2ac plus 9b over 12a squared bc. Here's another addition problem, but this one's easier because these already have the same denominator as each other. So we keep that same denominator, x plus 3, in the answer, and just add together the numerators, x plus 1 plus x plus 5. When you combine like terms, that adds up to 2x plus 6. So now we have 2x plus 6 over x plus 3. We've added correctly, but we're not finished because that can be simplified. The numerator, 2x plus 6, can be factored into 2 times x plus 3, and then the x plus 3 on top and the x plus 3 on the bottom cancel and leave us with just 2 for our final answer. Here we have a subtraction problem. X minus 1 over x plus 10 minus x minus 4 over 2x plus 20. For subtraction, just like with addition, we need a common denominator. These don't already have the same denominator. Can you see how to get the same denominator? Here's a hint. This second denominator, 2x plus 20, if you factor it, factors into 2 times x plus 10. So the first denominator is just x plus 10. It would match the second denominator if we multiplied it by 2. So I'm going to multiply by 2 on the bottom and also on the top of the first fraction. That gives me 2x minus 2 over 2 times x plus 10 minus x minus 4 over 2 times x plus 10. Since they have the same denominator, that's the denominator of the answer, 2 times x plus 10. And the numerator is made up of this numerator minus this numerator, 2x minus 2. And then we are subtracting x, and we are subtracting negative 4. And when you subtract a minus, that's the same as adding a plus. So combining like terms up there, the 2x minus the x is x, and the minus 2 minus a minus 4 is plus 2. So for the final answer, we get x plus 2 over 2 times x plus 10. And another subtraction, 2 over x minus 3 minus 3 over x. To get these the same denominator, I have to do it by multiplying, and they don't really have any common factors, but I'll just have to get my common denominator by multiplying the first denominator by x and the second denominator by x minus 3. And then both denominators will have x minus 3 times x multiplied together. So I multiply the denominator and also the numerator of the first fraction by x, 2x over x minus 3 times x. And I multiply the numerator and denominator of the second fraction by x minus 3. So then the answer has that common denominator of x times x minus 3, and the numerator has 2x minus 3x plus 9, because it's minus 3 times minus 3. And after combining the x terms on top, that gives me negative 1x, or just minus x, plus 9 over x times x minus 3. I'm going to stop this video here, and I will come back in a second video and solve some equations.